Okay, this is an oscilloscope. Once you've arranged the waves so you can actually look at it and kind of analyze it, it looks nice and pretty and looks good. So first of all, it's important to remember that the volts is the vertical and the time is the horizontal. The other thing we need to remember is divisions. Okay, divisions are these squares. So like for example, this right here is a division, one division vertically and one division horizontally. So you can think of a square as a division. Okay? So let's first of all find what's called the peak to peak, nope, not that one, the peak amplitude, which is just called the peak voltage. And so if we want to find that, we notice it's half here and a whole division there. So our amplitude is going to be 1.5 divisions, but we've got a problem here. We need it in volts. And if you look over here, it says each division is 2 volts. So I'm going to write 2 volts for every division. Divisions cancel. 1.5 times 2 means you have 1.5 2s, which means you have 3 volts. And that is your peak amplitude. Okay, that's how you do that part. So that's easy. So now what we're going to find is the period. And the period of a wave is represented by the capital letter T. And it is also usually on a wave. When we look at a wave, we look at it like this. And we think that this is wavelength. But if this is time in this direction, you can see it starts on top, goes down, ends up back on top. So that'd be one period of a wave. And the problem over here is we don't have two, on the left side in the actual diagram, we don't have 2 humps on top. So what we're going to have to do is start at one point. So I'm going to start here and keep going down, back up. We think it might be here, but you see it goes up here and goes back down. So this is actually the full length of the wave there. So that's your period. And notice it's 1, 2, 3, 4, 5, 6, 7, 8 divisions. So now we know our period is 8 divisions. But again, we're not done. So we need to multiply by, well, there is 500 microseconds. That little symbol stands for microseconds. That symbol is micro. So microseconds. And then we, per division. And the divisions cancel. And now you see that we get 8 times 5 is 40. Okay, so that's 4D, and then add the zeros, so there's 1, 2. And then after that, what we do is it's microseconds. So that is the answer to the next question. What is microseconds? What is the period of the wave? It's 4,000 microseconds. And now I'm going to pause you for just a minute and show you something else. 4,000 microseconds is actually the same equivalent thing as something else. Micro stands for 10 to the negative 6, or 1 millionth. Okay, so that's 4,000 times 10 to the negative 6 seconds. Well, that will help. And let me show you where that will help. So, we discovered the period was this, but we know the period equals 1 over the frequency. And if that is true, we also know that the frequency equals 1 over the period. And so if we want to find the frequency, it's equal to 1 over 4,000 times 10 to the negative 6 seconds. And if you do that in your calculator, you end up with 250 times 1 over a second, which is the units of a hertz. So again, 250 times seconds to the negative 1, or 250 hertz. Okay, hertz is the cycles per second, or just 1 over a second, or second to the negative 1. So that's how you find the frequency. Hopefully that helps. But a lot of students really struggle understanding that when you have 4,000 microseconds, that is actually 4,000 times 10 to the negative 6, and then they have a hard time putting that right here underneath the 1 and inversing it, and getting 250 hertz. So that's the frequency. Okay, that would be it. Hopefully that helps.